Hello everybody, nice to see you. Welcome to Ask Math Anything. Well, it's nice to be able to have this chance to catch up with people once in a while. And what we try to do is we try to be able to answer questions that people might have if they're curious about math. The kinds of questions that you can ask can range across algebra, geometry, and even things that are a little bit later. But I will choose the questions which I think I can explain to people who are still learning about algebra or geometry. If you have been here before, welcome back. I'm happy to have this chance to keep doing these with you. Let's go ahead and start talking about some problems. What do we have today? I see. Some people said different intro. That appears to be what we had today. Yeah, a different intro in some sense because we've had less of these live streams and you know, unfortunately we're going to have to do some more adjustments. But don't worry, these will come back later, I hope. Okay, what kind of questions do we have here? I see that some people are trying to do subtraction. Apparently you can read my shirt and it says 2014. And so if I start this live stream with simple subtraction, I guess that means that it's 2020 minus 2014, which is 6 years old. All right. Okay. Let me see. I'm trying to look at all of these. Okay, somebody has asked, Vera Wang has asked, I'm in 5th grade, is it suitable for me to learn precalculus? Well, it's always suitable for you to learn precalculus unless you have already learned calculus. I mean, what is precalculus anyway? Precalculus is the kind of math that you do before calculus. So as long as you haven't learned calculus yet, you are learning precalculus. Even when you are 1 year old and 2 years old, that's all precalculus. But I think what you were referring to is you were referring to the class called Precalculus. The class called Precalculus, I'd say that, generally speaking, that happens to be about topics like trigonometry, logarithms, and graphing all kinds of strange functions. If you find it interesting, I guess you could, but I think that the more important thing to do at that grade is to go and play with harder questions, math counts questions. Math counts questions can be pretty hard even though they only use algebra and geometry and, you know, a few more things that are around there. Okay, I just lied. They also use combinatorics, number theory, and probability, but all of those are not extremely difficult if you learn them the right way. You don't need to have lots of college math to do that. Let's see. What other questions do we have here? I'm looking to see what we have. So I see somebody asking, how many subsets of the numbers from 1, 2, up to 10 have exactly 2 prime numbers? Let's do that. I might have read it a little bit wrong. Oh, I see it. Exactly 1 or 2 prime numbers. Let's do this one. How many subsets of the set 1, 2, 3, up to 12 have 1 or 2 prime numbers? How many subsets of the set 1, 2, 3, up to 12 have exactly 1 or 2 primes? Now that's a fun question. If I want to do this, I guess I should do 2 kinds of problems. I should decide whether it has 1 prime or 2 primes. Is that right? Or maybe I can do it a different way. Maybe the way I'll do it is I'll say, let's go and put all the prime numbers in a pile, and then let's put all of the non-prime numbers in a pile. Let's try that. So what are the primes? The primes are 2, 3, 5, 7, not 9, but 11. Okay, so I have here 5 prime numbers. That's just what I wanted to do to count them. I have 5 prime numbers. And I also have the not primes, but I don't actually care what they are. I'll just say the number of not primes is 7 of them. Not primes. And we'll just say 7. Let's do this. Let's draw a little brace and write a 7. And inside there, who cares? It's like some numbers are there. It doesn't matter. So I have 7 not primes, I have 5 primes, and it's easy for me to do this because I just take the 12 minus the 5 and get the 7, so we're good. Alright, so the next thing I want to do is I want to know how can I get exactly 1 or 2 primes. If I want exactly 1 or 2 primes, I guess I take these 5 numbers, and I either choose one of them or I choose 2 of them. That must be it. So what I have to do here is from the 5, I have to choose 1 or 2. Everyone knows that's just called 5, choose 1 or 2. Right? Not really. I don't think we're supposed to write things this way. This is just a bad joke. When you write like this thing and like some number up there and some number down there, it means something choose something, right? Yes, question mark is the correct answer. I wrote some complete nonsense. Do not try that at home. Okay, that's not what you do. What you actually do is you do what's called 5 choose 1 plus 5 choose 2. Okay, that's what we actually do. And when you go and write this thing in this column with this parentheses, it just means something choose something. The number of ways to choose that many things from that many things. And the number of ways to do that is exactly equal to, I saw someone write 15. It's 5 choose 1 is 5. That's the number of ways to choose one thing from 5 things. Plus, if I want to choose 2 things, it's 5 ways to choose the first one, 4 ways to choose the second one, divided by the number of times I could have chosen the same thing, just in a different order. Okay? So that's 5 plus 10, and that's equal to 15. Well, that was nice. Once I have this 15, now what do I do with the 7? It's obvious! You just take 15 times 7. No, it's not 15 times 7. You want to say there's 15 ways to do the prime part, and then for the non-prime parts, for each of those not primes, it's either there or not there. Right? Because I don't care what I do with the not prime. So I can say, let's take the 1. Let's take the 4. But I don't like 6. Stuff like that. So it's like times. Oh, yes. Somebody said not prime equals composite. There's a reason I wrote not primes. It's because there is a number that is neither prime nor composite. You see, Vera, thank you very much. It's 1. 1 is not prime and not composite. Actually, there are more numbers. 0 is also not prime and not composite. -1 is not prime and not composite. Pi is not prime and not composite. Okay, there's lots and lots of numbers that are not prime and not composite. But when we're talking about these positive integers, 1 is also neither. So that's why I just wrote not primes. Okay? And so people already got it. What you do with that 7 is you multiply by 2 to the power 7. Because for each of those numbers, it's either in or not in. Each of the not primes, in or not in. So if I multiply all this together, what do I get? Oh, who likes multiplying? Should I go and take 128, which is this, times 15? How many people want to do this kind of a calculation? 128 times 15. Is this fun? No, this is not fun. There's a much easier way. The easier way whenever I see a 15 is to say, oh, let's grab one of those 2's and make it a 30. So this is also equal to 30 times 2 to the 6. Now 2 to the 6 is 64. So this is a lot better. 64 times 30. Oh, this is good. I don't know if anyone else writes this way. When I'm doing this, I'm just going to throw the 0 at the end. It's legit. So we have a 0 here, and I have 3 times 4 is 12, 3 times 6 is 18. Really? Is it really 1920, or did I screw up? That seems like a nice number. Maybe that's right. Okay, so that's the answer. 1920 is the answer. Nice answer you've got there. Nice problem. Thanks for sharing it. I didn't expect the answer would be this nice. I mean, 1920. I see 1920 all the time. Does anyone know where else you see the number 1920 in the real world? Besides if the year was 1920? Does anyone know where Yes, made in 1920. That is one place. Yes, there's this 1280, 640, 1920. Is there anything else like in your daily life or in any of the like stuff you use where 1920 appears? There is something where 1920 appears. The last pandemic was 1920, a century ago. Yes, that's what I wanted. Vishme, 1920 by 1080 resolution. That's exactly right. Has anyone ever noticed before that if you have a screen, sometimes the screen is 1920 by 1080? This is what's called 1080p. Yes. People call it 1080p resolution. This stands for 1080p. Okay. And so this is nice. I mean, the 1920 appears. But does anyone know why it's 1920? Why people chose 1920 and 1080? There's a reason. Or HD. Actually, I believe this is called FHD. If I remember correctly, HD was 720p. And indeed, Spaced Out is watching on 1080p. Wonderful. Yes, that's right. They felt like it. No, there's a really good reason. It's because it makes a 16:9 ratio. They add up to 3000. Oh, that's cute. I didn't think about that. But it's a 16:9 resolution. This is what we call 16:9 aspect ratio. Oops. 16:9 aspect ratio. So 16:9 means 16 across and 9 up and down. And the aspect ratio is actually is how you say, like, you know, how wide to how tall something is. And it used to be that people did everything in what's called 4:3, but then people moved to 16:9. Some people even use like 21:9. But the bottom line is that somehow these are the ratios for screens. And 16:9, once you have a 16:9, that's actually why 1920 came up in our calculation. You see, because in our calculation, we got our 1920 by multiplying a big power of 2. We multiplied 2 to the power 7 by 15. And if you have 16:9, the fact that there's already a 2 to the power 4 explains why the number up there should have power of 2 even bigger than 4. Daksh Gupta asked, why was 16:9 better than 4:3? That's a good question. If I wanted to make up an answer, which I think might make sense, the answer I would give is, if you just looked straight ahead, what's your field of view? We can all experiment with this, right? So I'm going to go and stare at the camera now, and I'm looking straight at the camera, and I'm holding out my arms, and this is just me experimenting because I've never done this before. I'm just focusing straight at the camera and trying to figure out when I can't see my arms anymore. Do you know what I mean? That's called the field of view. So at a certain point, your arms sort of disappear. Wow, this is pretty crazy. I can still sort of see my arms out of the corner of my eyes. You guys can try this, right? This is insane. This is huge. But what's my field of view vertically? Now I'm going to try. And it's like vertically, when do my arms disappear? Like around, oops, I should stare at the camera. Like around there. So if you notice what just happened, it's like my field of view wasn't as wide vertically, but it was very, very wide horizontally. And oh yes, Susan, you're right. There's also your eyes blind spot, which is also kind of interesting. But the important thing here is that your eyes have a field of view which is like much more horizontal than vertical. And I'm just doing this so that you can do it yourself. You know, you don't have to take my word for it. Just do it. Just like concentrate at one spot and just like move your arms, and you'll be like, oh my goodness, I can still see. And then over here, I can't really. So now you just think about it and you're like, well, if I'm going to watch a movie, it would be a lot better if the movie was where I can kind of look at the screen and kind of see more stuff off to the side. That's actually why people are even making 21:9 type of film. But now if you're wondering, oh gee, then why didn't they just do this in the beginning? I have a hypothesis. My guess is because the camera, the lens, you know, like things that are recording, it's a lens. And then there's like something capturing it afterwards. The lens sort of focuses, there's a circular lens, it focuses things on circles. So if you actually use a field of view, I mean, if you have the recording part only be this tiny thin rectangle, you're actually wasting a lot of pixels. You're wasting a lot of stuff that you could capture in focus. What I'm trying to say is if you had this part here that you were able to focus on, because of your lens. Suppose that was the, oh, that's such a lumpy circle. Okay, let me try again. Maybe a little bit better. But if you had this circle, I'm saying the circle is like, you know, lenses like on cameras, they're like circles, right? So you have this lens, and the lens has a certain part inside the lens which is like in focus. When I say inside the lens, it's like the lens is capturing all that light and it's focusing it on a certain area. That area might be somewhat circular given that the lens was a circle. And if you have this, look, if you decided you wanted to like use, this is the part that you can record. Suppose this is the part that you can record clearly. If what you record is something like this, if that's the part that you record, that's pretty good. You're recording a lot of pixels. You're recording a lot. But if you instead try to do something which is like a wider field of view, if you decided to record this, then it's like you didn't do you know what I mean? Like there's all this other stuff that could have been in focus, but you only recorded this little bit. So that's actually somehow, I just made this up, by the way. I could be completely wrong, okay? So if you're looking things up, you might be like, this guy doesn't know anything. He's just a math guy. But I'm telling you, just like what I'm thinking about as a math guy, I'm like, well, I could see how it would make sense from a geometry perspective of why you might normally want to use more of that area that you can record and therefore get aspect ratios closer to squares. That's like maybe more efficient. But maybe because people wanted to have these wider things, as technology got better, we could throw away more of the pixels. I just made that up. Okay, right. But actually, here's another thing. I don't think this part is made up. But do you know why? Oh, wouldn't 1-to-1 be better? 1-to-1 would be better if you somehow were expecting to kind of look up and down in the movie theater a lot, right? Okay. Maybe let's go on and do math. We're sort of done talking about movie technology and like physics. Let's do some math. Oh, I like this one. Okay, here's a question. It's a question by Jeffrey Liu. It's a long division problem. You want me to do a very big long division. You said x squared minus 5x plus 3c. Okay, and we're going to divide that by x minus 3 has remainder 12. And the question is, what is c? How do we do this? Well, first of all, you have to ask, what does it mean to divide? Uh-oh, did I type it wrong? No, the remainder is 12 on my thing. Jeffrey Liu says remainder is minus 12. So let's just go change the question. It was your question. If you want minus 12, it's minus 12. Minus 12. Okay, we can do minus 12. So now how do you do this? Well, when you do this, C is a programming language. That is true. But when you do this, what does division mean? Division means that you write x minus 3 times something. So this exactly means that x squared minus 5x plus 3c is equal to x minus 3 times something, okay? So there will be a something, and then minus 12. It's just like what happens when you normally do any division, right? When you do any normal division, it's like if I divide 65 by 2 and there's a remainder, it's 65 equals 2 times something plus the remainder. But this thing in here, it's something, some nonsense, like x-ish nonsense. X stuff. It starts with x and then it keeps going and it's blah, 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 blah. Okay? So this is blah, blah. I guess blah has an h. Okay, so it's like x, blah, blah, blah. But you're just multiplying these things together and there's a remainder of minus 12. So we just need to go and figure out what is c. Now there's two ways to do it. One way to do it is to go and use this long division method. But that's not really what I need. Instead, what I'll say, that's one way to do it, but there's a better way. The better way is to say, you know what? If there's a blah, 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 I would love to multiply blah, blah, blah times 0. Because you see, this is the difficult thing. Does anybody know what is blah times 5? No, I don't know. It's just like blah, 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 blah. Oh yeah, 5 blah. Okay, right. But you it's like some nonsense. Okay, it's even worse if you have like blah to the power of blah. Also very bad. It's like, blah, blah, blah. What if blah was a fraction? I don't know. Okay, it's bad. But you know what I can tell you for sure? What is 0 times blah? Now that's good. 0 times blah, 0. By the way, blah is a legit number. I'm saying blah, if I had a blah, it was like some number, okay? It's not going to be infinity. It's a real number. So 0 times blah, just stop the blahing. It's just 0. Okay? That's the hint. So if that's the case, can anyone suggest a good thing to substitute in for x? If I have this thing, and it has blah, blah, blah in it, What should I plug in for x in this equation to get something interesting? X equals 3. Look, if I plug in x equals 3, 0 times blah, it's gone. Okay, let's do it. So if I have this, now what I do is I plug in x equals 3. Okay, now it's going to be powerful. So if I plug in x equals 3, I get 3 squared minus 5 times 3. This is a times, not an x. Oh, I just realized why the times is like a little dot. It's like if I draw a really, really small times sign, it looks like a dot. Okay, and then plus 3c. I don't know what's c yet, but we're going to find out. Equals, 0 times blah. That's 0 minus 12. Okay, I think we're almost done. So 3c equals. Now is the hard part. We got to do some arithmetic. So I have a minus 12 on the right. I had a plus 9 on the left, so I subtract 9. That's the 3 squared. And then I have to plus the 5 times 3 is 15. Okay, already I'm happy. The reason I'm happy is because I see that these are all multiples of 3, and I see a 3. And if I want to simplify this, the 15 minus the 12 is 3. 3 minus 9 is, do you see what's going on? 15 minus 12 is 3. 3 minus 9 is negative 6. So C looks to me like minus 2. I think that's the answer. Great. Yes. Does anyone know what is blah times negative 1? It is halb. Okay, I think I'm done with the blah jokes. Let's go and do more problems. More questions. Here's a question that I don't know what to do. I don't know how to do it, but it looks cute. This is a question by Shirley Xu, and it looks like a geometry problem, but what is it? I have to read the question to find out. I start with a 5-inch square. 5-inch square here coming up. Close enough. Let's call it a 5-inch square, okay? Next thing that happens is that 1-inch squares are cut from the corners. So I guess I have to cut off some 1-inch squares. Let's pretend that these are 1-inch squares. This is not necessarily drawn to scale. It might be a bit off, but it's also not that far off. Okay? That is totally not a square. Okay, so we cut off some 1-inch squares. Sort of. Again, not quite to scale. Maybe those squares can be a bit bigger, but we have this. So 5-inch square, and it looks like I'm marking right angles. You know what? It does, but I'm not. I mean, it does really look like I'm marking right angles, but I'm just trying to say that I'm cutting off these 1-inch squares. And now, oh boy, what is the area of the largest square that can fit in the remaining space? So you want me to stick a square in there. So we need to go and fit a square inside that remaining space. What would that look like? Well, obviously, the biggest one that you can put is like this, right? Who thinks that's the biggest square that I can put into the remaining space? No, it can't be. Because if it was, then this question would be too easy. So what should you do? You should start turning the square. Because if you turn the square a little bit, it's got some more space. Okay, so now, if I know I can turn it a little bit, now the question becomes, how far do I turn it? I guess I sort of would want to turn it so that, I guess I would want the end points to be on these things. Oh gee, what can I do? This is actually pretty interesting. I don't know the answer yet, and that's why I'm curious. So if I look at this, I say, I could make any square here's what I'll do, okay? Here's what I'll do. First, I'll look at this square. Here's another square. Remember, the area of the last one was 9. Does anyone know the area of this one? Do you know the area of this square? The area of the first square was 3 by 3. That was 9. That was clear. But what's the area of this square? This is a really fun calculation. The way that you do this area is it's just half of the area of the whole thing. It's really nice. The reason why it's just half, you can see as soon as you draw some lines. If you just cut it like this, zoop, zoop, then it's clear that the inside and the outside are the same area, right? These two are the same. These two are the same. These two are the same. And how do you turn your hand that way? But okay, these two are the same also, right? So somehow it's exactly half. Half of the whole area is inside and half of the whole area is outside. So in this case, I've just managed to make a square whose area is half of 25. What's half of 25? 12 and a half. That's pretty good. That's exciting. So I can get 12 and a half. And 12 and a half is more than 9, right? So that's good. I got more. First I had 9. Now I have 12 and a half. But once you look at this, you say, oh, could I actually make it bigger? How could I try to make it bigger? I could try to turn it. I mean, so far I'm not even using those little things, right? So if I'm not using those little things, I should probably turn it until I get stuck, right? I should turn it until the moment that I actually legitimately get stuck. And what does stuck look like? Stuck. Wow, I don't know if I can even eyeball this. But stuck might look something like this. That was lumpy. What am I doing? Let's go this way. Yeah, like that, right? So I made a very lumpy square. But the reason I made a lumpy square is because it's hard to be able to tell. That does look amazingly bad. But at least we now know what we're going for. We're going for this problem. So if we're going for this problem, we just need to go and figure out what's the side length of this piece of American cheese. Actually, when I look at this, I think of this like yellow cheese. I don't know if anyone else can imagine what I'm talking about. If you don't live in America, you may never have, maybe you've never experienced our wonderful invention called American yellow cheese. But this is like a piece of American yellow cheese. This is a key ingredient in the all-American McDonald's hamburger. Actually, no, it's in the McDonald's cheeseburger. But anyway, let's keep going. So we have this thing and we want to go and say, how long is this piece? And I do know, it's not cheddar, by the way. If anyone was wondering, if you think it's called cheddar, when I lived in England for a while, some people taught me that there is actual cheese, which is not the same as this American cheese, which is, I see Eric Feng is not entirely sure that American cheese is cheese. It's because there's something called cheddar and there's something called American cheese. Okay, anyway, let's keep going. Now we want to know what is this length, and here's what we'll use. It's 5 across. If it's 5 across, now we have to go and give some variables. Let's solve this problem, okay? So, I get it. So if this thing here was x, this thing over here is obviously 5 minus x. But in that case, since this is a square, and this is going all the way around, this part is also 5 minus x. Strictly speaking, that's because of something called congruent triangles. But you can probably see it. It's just because this length here on this square is the same as that length on that square. So whatever was going on in that triangle just turns this way. So now, over here, I have a 5 minus x also. And now that should be enough information. I'm basically saying I have an x, and I have a 5 minus x, and I have a 1 by 1 square inside. What is x? Let's go and draw another picture. Now, the entire game is, I have this, and I have this. And I have the triangle that it makes. And there's some kind of a square that's stuck inside, which is like 1, whoops. Let's go here. This is like 1 and 1. 1 and 1. And the other two parts add up to 5. This is a really neat question. So here's x. Oh, I see what I want to do. So if that whole thing is x, the reason I said, oh, I see what I want to do, is I want to put the x high enough that I can have some more space. That's x. And this is 5 minus x. Now, why did I leave more space? I left more space because I want to put some 1s here, right? This is a square. So I always like to solve a geometry problem by writing down all of the lengths that I can write. That's a 1, and that's a 1. And if that's the case, now I can write some more things. If that was 1 and the whole thing was x, then this is x minus 1. Let's write that down. X minus 1. And this thing, if there was a 1 here, then this is 4 minus x. Okay? Oh, we did this question already? It could be. Maybe we did this question already. I wonder if we did this. So if we did this already, we're going to do it super fast. As you can see, the way I do problems is I just kind of do them whenever they show up, and I don't remember the problem. I just kind of figure it out as we go. But yes, Professor Loh has bad memory. That is correct. And if we did this, then let's just finish then. How do we do this? It should be very simple. We've got some similar triangles, right? So this thing here is similar to, well, the whole thing. We can do that. Which is the easier one? No, the easier one is this little guy is similar to that little guy. By the way, I might have done it in a different way before. The way I'm going to do this one this time is I'll say this little one is similar to that little one. And here I'm going to use pink. These are similar to each other. Because they're similar to each other, I can take ratios. X minus 1 over 1 is equal to 1 over 4 minus x. I'm not sure how I did it last time, but this is how I feel like doing it this time. And so I do this divided by this equals this one divided by this one. Solve it quickly since we've done it before. I multiply across. That will give me minus x squared. That's the minus x times x. I have an x times a 4. I have an x minus x times a minus 1, so that's plus 5x. And then I have a minus 4 equals 1. Hopefully I didn't screw up. I think that looks about right. And let's put it all together. Now I have x, if I move to the other side or flip the sign, I get x squared minus 5x, and it should be plus 4, and then now it's plus 3 equals 0. Oh boy, okay, so it's something ugly. All right, so let's just solve it really fast. X equals, wow, this was problem number 25, huh? So x equals 5 plus or minus, wait, the answer is just something that nice? People are saying the answer is 15. I'm getting something bad. That means there's an error. Error. Where's the error? So there could be an error. So if there's an error, I did it wrong. What happened? Let's see. So if that was x and that was 5 minus x, then what happens? I did make a mistake. Where's my mistake? You subtracted 2 from both sides. Wrong. Maybe I did. So let's see. So I had this. If I try to multiply, it should be plus 4. Yeah. Okay. Ooh, yes, that's right. Wrong. This should be plus 5. Okay, so now it's plus 5. Yes, hopefully that's right now. Because if I was trying to do too many steps too fast, I should actually subtract 1 first and get a minus 5. Okay. Wait, you're saying that the 4 minus x is wrong? Is there another problem? Let me know if there's another issue. So the whole thing is 5 minus x minus a 1 is 4 minus x. Seems to be okay. Okay. But what I'm saying is that this is still coming up with some very ugly numbers. So let's just keep trying. Okay. So if I have this thing here, then I have, the quadratic formula will give me negative this plus or minus the square root of 25 minus 20 all over 2. So if we've got this, what are we wrong? So is there something wrong? Let's see. People are saying that there is something wrong. And I'm just double checking here. Now some people are saying not wrong. Let's find out. So if I have this thing, what happens next? What happens next is I get 5 plus or minus the square root of 5 all over 2. Wow. Is it 5 plus or is it 5 minus? What do you think? What do you think is x? Do you think x is 5 plus the root 5 over 2 or 5 minus? Well, the good thing is it's both. The reason it's both is because you can either put it this way or you can slant it that way. So those are the two options. So now we know that one side is going to be x, one side is going to be 5 minus x, and those two sides are these. Okay, so now we're almost done. Now we know that we have a right triangle, and the right triangle has a side of 5 minus the square root of 5 over 2 and 5 plus the square root of 5 over 2. And we just need to know what is the area of this American cheese. Well, let's do it this way. let's just take 25 minus 4 of these. That'll be easier. I don't want a Pythagorean theorem it. I'll just take the 25 minus 4 of these. Well, what's the area of 4 of these? The area of 4 of these is 2 times the top times the bottom. Like 2 times that one times that one. Okay? So 4 areas. My head's running into the way. So 4 area. So hang on a second. So if I want to find out the area of 4 of these, 4 times the area is then equal to, I guess the 4 is going to cancel with the 2's. The 4 is going to cancel with the over 2 and the over 2. And I just have 5 minus root 5 and 5 plus root 5. 5 minus root 5 times 5 plus root 5. That's easy. That's called a difference of squares. Okay? So now if I do this, I will just take, the 5 times the 5, which is 25, minus the root 5 times the root 5, which is 20, which is 5, and I get 20. Something is wrong. No, I'm off by a factor of 2. Excuse me, this is wrong. 4 times the area is going to be this thing times a half. Because it's like 4 times this times a half. Much better. And the way I know it was wrong is because if I'm saying that I'm subtracting out 20 and the answer is 5, something is wrong. So I need to take this times a half. That's 10. Hey, look at that. We got an answer. So the answer is just going to be 15. Because I have 25 for the whole thing minus the 10. So the answer for this wonderful slice of American cheese is 25 minus 10, which is 15. Okay, and that's the answer. Nice. Huh, that's cute. Looking at this thing makes me think, I didn't expect the answer to be that nice, but good. And this is indeed more than the 9, and it's more than the 12 and a half, it's 15. All right, more questions. What else do we have today? And thank you, Shirley Xu, for asking this. Oh, Firestar7890 says, there is a much easier way, though, that doesn't require radicals. Now I'm curious. Is there a much easier way to do this? So let's see. As I look at this, I'm trying to think, what would that much easier way look like? So, oh, yes. Okay, that's neat. Thank you. So now I see. So what you're saying is, oh, I like it. Product of roots. Thank you very much for sharing this, right? You see what I eventually did? I eventually took the x times the 5 minus x. But given that the x and the 5 minus x are the 2 different roots of this, that's what we saw at the end, we don't need any of this, right? The answer was going to be 4 times the product of the roots of this equation. And the product of the roots, that's not 4 times. 4 times the product of the roots times half. I like it, yes. So the product of the roots, if I have x squared minus 5x plus 5, bam, the product of the roots is 5. So you could actually have gotten the 5 right away. You'd have said the product of the roots is 5. Wait. Something's still fishy. X is, yes, that's right. So I want to have 4, oh yeah, right. 4 times the product of the roots times half. Perfect. So 4 times the 5 times the half, which is 10. And we'd have gotten this 10 immediately. Thank you for sharing that. That's actually very, very clever. Ah, I've learned something today too. Okay, more questions. Oh. It looks like we're doing a lot of these geometry questions. Let's do another geometry question. This is by IS, okay? IS has a question which is about a rectangle, but this rectangle has some coordinates. I need to draw where these coordinates are. These coordinates all seem to be in the right half, so let's start with that. Let's get ready with something huge. Huge. How huge? Kind of this huge. Huge. Now if I have something, oh, LS. Nice to meet you, LS, not IS. Okay, LS. So I have a point A, which is at 6, negative 22. That's a reasonable point. 6, negative 22 looks something like this, maybe. Okay, so that's at 6, negative 22. Now, if I said 6, negative 22 is the reasonable point, what is everything else? Oh, I'm sorry, LS, I just didn't read it properly. You don't need to change your name. I mean, you're reasonable. Okay, I also have a point B, which is 2006, 178. I guess my picture is not drawn to scale at all. Let's fix that. Nah, well, can we draw it to scale? If we drew it to scale, it would be like here somewhere. This is 6, negative 22. Okay? That's the point. And then I have another point, which is 2006, 178, which is going to be something like this. Far, far, far away. 2006, 178. Okay? And that's the point B. Oh, these have names. This is the point A. This is the point B. Okay. Now, if I have a point A and I have a point B, I also have a point D. The point D is at 8, y. And there's a rectangle. It goes A, B, C, D. Huh. Okay. So I have a AB, and I have a C, and then I have a D, but the D is at 8, y. So the D is somewhere here. It's just to the right. And if I want to make a rectangle, how could I do that? I could go A to B. Ah, okay. If I make AB one of my sides, and I want to make AB CD, where D is going to be at 8, I think the rectangle looks something like this. So here's one side of the rectangle, AB, and the sides of the rectangle are parallel. Okay, so there's going to be some other line, and if I went that way, by the way, if I went that way, it would be A, B, C, D, where D is less than 6. See, I even fall off the screen like this. But if I need to make it where the point D has a coordinate which is 8, then I have to go this way. Okay, so there will be another point, D, which is exactly where this arrow is, which is really annoying. So let's draw the arrow this way. 6, negative 22. That's this point. And then there's another point which is at 8, something. To be honest, it probably looks something like this. Some ridiculously skinny rectangle. What happened to my rectangle? Drawing parallel lines is really hard. So B is up here. And there's another point here, which is C, and then this one here is D. And D is at 8, something. And the question was to find out what's the area. 8, y. I don't even need to write y. I'll just write a blank. Okay? Does the question make sense? Drawing straight lines is really hard. You see, drawing one straight line is hard, but drawing two straight lines close to each other is ridiculous. Ah, people are talking about slopes. That's right, we should talk about slopes. So if I want to do slopes, well, I've got one thing which is going off that way. What's the slope of that one? And the slope of this one, the two slopes, since I have a right angle, multiply to -1. So what's the slope from the line AB? Let's find out. Slope of AB is the rise divided by the run. Oh, I like subtracting these numbers. Oh my gosh, you gave me nice numbers. 178 minus negative 22, that's going to be 200. Divided by 2006 divided by 6, sorry, minus 6. 2006 minus 6 is 2000. So this is 1 over 10. Okay, so if that slope is 1/10, this slope is -10. And if the slope is -10, if this is going to be 8, well, I've gone across by 2, so now I need to go down by 2 times 10, which is 20. If you go down by 20, you get -42. Let me get more space by clearing this off. -42. Okay, now I can just go and try to figure out what's the area of this rectangle. I have to go and figure out how long is that times how long is that. Is that the best way to do this question? A little bit of me is wondering how lazy I am here. Is there a better way to do this? Oh, yes. Do I want to do it that way is the next question. So there's like two different ways I can try to do this. One way I could try to do this is I could actually just go and put the whole thing inside a big rectangle and subtract. I could use the big rectangle and I could subtract out the areas of the 4 little triangles. That's one way. The other way is if I was brave enough to go and figure out what is actually the length of this diagonal. Oh yeah, I can do that though, because the numbers are nice. It's a 1 to 10. Let's do it that way. Okay, so I have something which is 1 up and 10 across. So when I look at this particular length is exactly 200 times the length of something which is much simpler. The length of the 1, oh, I should probably label these with a different color. 1 and 10. Does this make sense? If I could figure out that thing and I multiply it by 200, then I get this length. That's much better. Okay, so this is actually not very painful. So in that case, what is this? This is the square root of 101, because the square root of 10 squared plus 1 squared is the square root of 101. So this is equal to 200 times the square root of 101. Okay, 200 times the square root of 101. So now let me go over to this side. If I want this side, it's going to be 2 times the square root of 101. It's 2 times the square root of 101 because I go across by 2 and up by 20. So over here, I have 2 times the square root of 101. So now it should be easy. I should just go take 200 times the square root of 101 times 2 times the square root of 101. That's 400 times 101. I can do that. That's a kind of arithmetic that I can do. I need to do 400 times 101. And that's just equal to 40400. Okay. And I guess that's the answer. So that wasn't so bad at all. When I looked at the question in the moderator chat, I wasn't sure whether the answer was going to be nuts. But it's okay. It's raisins. Well, I mean, it was reasonable. Okay. More questions. Error 40400. You guys are funny. Vivian Shen. How to remember how to calculate slope. You see, the important thing here wasn't really that it was reasonable. Oh, there's someone here who's pretty funny. Okay. But now somehow, is it important that the slope was the rise over the run? Not really. If you just use that the slope was the run over the rise, that's okay. And you just did the same thing on both of them, you'd still have the right answer, because somehow the product of the, oh yeah. This is important to know. Like if you did the whole thing in terms of the run divided by the rise, that just happens to be the, what is it? The apples, right? If you just use the apples instead, you'd be okay. So it would be completely reasonable. You could just do the whole thing with the apples instead, and then somehow the apples of this line and the apples of that line multiply to -1. Still okay. All right. More questions. Yes, I think we had talked about apples at some point on this live stream. This shows that there are some people here who have been here quite a long time. All right. Rohit Kumar. What is e to the power infinity? Well, unfortunately, you can't really have a power infinity, but in this case, since you take e is a positive number which is bigger than 1, like 2.718 and so on. If you keep taking more and more and more bigger powers of e, it just gets to be bigger and bigger and bigger, and it goes without bounds. So you could say that e to the infinity is infinity. That would actually be reasonable. Okay, more questions. Anonymous Panda. Is there a quick way to solve the problem where there are 2 cars coming towards each other and a fly is flying in between? How much distance does the fly travel when the cars collide? This, by the way, is a very depressing problem. Like you're saying there's 2 cars coming together, and then there's this fly which is just going to go back and forth between the 2 cars until they collide. I mean, and everyone here is only worrying about the cars, but like, what about the fly? Yeah, so this is a very unpleasant question, but the way that you think about these questions is you kind of go like, oh, yeah, there are two answers. It's very famous. One way is to add up what's called a geometric series, where the amount of distance that the fly travels in, well, like from one to the other is something, and then it goes back and that's something, and then back and it's something, and you add them all up, and it's reasonable. The other way is to say, just calculate the amount of time it takes for the collision to happen, and multiply that time by the speed of the fly. And that's kind of famous. All right, more questions. Pennywise, the dancing clown. You guys have very interesting names. If you have done 20 questions on AMC 10, and you have 5 questions you don't know how to do, how many questions should you guess on to get the highest expected score? All right, so now we actually need to know what is the rule for the AMC 10. And I don't remember, I don't pay attention to this, except I sort of do. So the AMC 10, here's all I know. AMC 10, it has 25 questions. Actually, we're going to figure out the rules. I happen to know that it has a maximum score of 150. In that case, I think we now know how much each question is worth. Each question is 6 points. Except that something else I also know is that people have like really random scores that have 0.5s in them. Like, why are there 0.5s in these scores? Well, because they do. And it's not only every 0.5, it's like every 1.5. So I now know that because I've seen this 1.5 pattern, and also because 1.5 times 4 is 6, so there's some nice number theoretic property. But because of this, I know that if you leave blank, you get 1.5 points. Leave blank, you get 1.5 points. What that means is, if you felt like it, you could just like turn in a completely blank exam, and if you left a completely blank exam, you already get 25 times 1.5, you get 37.5 points for doing nothing. So that's how the AMC works. You can hand in a blank exam and you still get 37.5 points. But now the problem is, you know, if you decided that you just wanted to guess instead, you could get unlucky. And if you just like got everything wrong, you'd get 0 points. Because if you leave blank, you get 1.5. But if it's wrong, you get 0 points. Okay, so now when you look at that, you say that the ratio is 1 to 4. So now you go and say, somebody's asking, I've got 20 questions done, there's 5 questions left. You know, what should I do? Should I go and guess or should I not guess, right? But now here's the deal. If you try to guess, right? If you try to guess, what's your chance of getting it right? And even if you're not familiar with that kind of probability, you can think of it this way. Suppose it just was evenly balanced. You did 5 questions. You know, there's like 5 answer choices. Oh, I didn't mention that. That's a very important point. 5 answer choices. Now, if there are 5 answer choices, basically what's happening is like 1/5 of the time you guess right, 4/5 of the time you're wrong. Okay? So now if you look at this, it's like somehow 1/5 of the time, that's hard to read, 1/5 of the time you're right. And then you get +6. But 4/5 of the time, you're wrong, and you get +0. Now, how do you deal with this? The way you deal with this is you say that means that on average, you'd get 1/5 of 6. That actually makes sense. Like, you know, on average, you have a 1/5 chance of getting a whole 6. So on average for each question, you would get 6/5 points on average by guessing, by purely guessing. So what this means is that on average, each time, you get +6/5 by guessing. And now 6/5 is lousy. 6/5 is 1.2, and 1.5 is better. So in fact, the optimal strategy the optimal strategy, if you have absolutely no idea, is that you should leave it blank. But now, what if you can rule out some answers, right? You know, sometimes there are some tests where there are some possible answer choices, and some of them are just flat out obviously wrong. Well, if you know that one of the answers is definitely wrong, like definitely wrong, then look at what happens. If one of them is definitely wrong, this becomes a 1/4 chance that you're right, and 3/4 chance that you're wrong. If you have a 1/4 chance that you're right, 6/4 equals 1/5. So if you manage to rule out one of the answer choices, then you're just as good as leaving it blank. So you shouldn't. On the other hand, if you have eliminated 2 of the answer choices, then it makes sense to guess. So that's the optimal strategy. Okay, more questions. Oh, let's do one more quick one to finish. One more quick question, general question. Okay, let's finish with this one. This is a motivational question. This is a question by Pritha Padmanaban. Pritha Padmanaban, nice to meet you. And the question is, Po-Shen Loh, Po-Shen Loh, what's the best way to motivate yourself? I think it's nice to have a sense of humor when you look at life, in the sense that, you know, things in life are sometimes good, sometimes not good, but try to find the good parts in it. I guess that just helps to be like an optimist. That's what I'm encouraging. It's just that whenever you're doing anything in life, you can always look on the good side or look on the bad side. I advise that you just look on the best side of everything, and that helps to keep you motivated. Keeps you from thinking that everything is all going downhill. You can even be like, oh my gosh, I even learned a funny word today. Like, what funny word did we learn today? We've learned 2 funny words today. One was halb, and one was apples, right? So I'm just being like, you know, whatever's going on in the world, take the world with a sense of humor. And if you do that, it can be and reasonable. We just learned about reasonable, which is the opposite of something being totally nuts, right? And so all of this thing is like, yeah, the it's a funny place. If I'm doing math, I'll be like doing some calculation, and I'll be like, wow, that was a nifty number. Or I'll be like, wow, that's the ugliest number in the world. I never thought I could get that. But that's kind of funny. It's an ugly number. I'm just giving. Oh no, you guys are even more funny. You said knots. Okay. Anyway, but I'm just giving that sense, like, you know, how to motivate yourself, whatever you're doing, even if it seems like a little bit boring. Find something that's nice about it. And I say this on purpose. It's because sometimes you want to do things that are useful, and the things that are useful are sometimes also unpleasant. I do that. I mean, as some of you know, I'm playing with this thing to fight COVID. And if you're doing that, sometimes what your job is not much fun. Maybe you're tired. But just look on the bright side. You know, look on why you're trying to do it, and motivate yourself by finding something small in what you're doing that's entertaining. All right. So unfortunately, we have run out of time today. It's also unfortunate that due to the Math Olympiad training program, I will actually not be able to do the session tomorrow. I will also not be able to do a lot of the sessions next week. So the website is going to update with when the next sessions are going to be. I'm still going to try to see all of you at least once a month. But, sorry, once a week, not once a month. I'll see all you guys like once a week at some point. I'll find one particular time. But the month of July is going to be kind of crazy. It's going to be kind of crazy. That's the problem. I'm sorry. I actually have to run a Math Olympiad camp here in the United States. But not once a month. It'll be like at least once a week. But I anticipate that by the time we get back to August, we might be able to get back to normal. So, sorry about tomorrow, but I'll see all of you next week, and I'll update the website. Have a great weekend, and good luck, everyone.